Okay, let's build a small example based on the timers and interrupts. And this application would be just blinking the LED. Guess what? The blue LED on the board at about 1 Hertz rate. Okay, so I will start from the scratch this time. So I have a blank screen, blank design, and I start there actually adding some components. So one way to search for components is search them. For example, I need that digital output. Okay, there we have digital output pin. And I will just use this as a software controllable pin for that blue LED. There, apply, and to be sure, on the sure side, I'll also try to remember, okay, port 2.1 is the blue LED pin. Excellent. Next, let's add a timer component. Okay, here I have a timer, and it already actually it's built of different components. It also has a component called interrupt in it. So basically, let's make this one a counting to 1000 of 1 kilohertz signal. I can then create a new clock at 1 kilohertz frequency. Okay, now I have set up the input, and then I can also make this one 16-bit and 1000. Okay, one selection you need to do on this the generic blocks is usually, are you using fixed function, meaning this is actually next to the processor level of the system, or are you using the universal device blocks on the or digital blocks on that second layer. I would prefer using UDBs as long as we have the available resources, since when you use the fixed function, then you have allocated that timer for that only. And okay, it's more, it gives more flexibility for the if you implement this as UDB. Okay, then next thing is to make it to interrupt. Actually, interrupt on terminal count, that's just fine. Or the capture would be another one. Basically, the capture mechanism, you can read more on this the data sheet, but anyways, it basically just means that when does this reload of the next value happen on that timer. Okay, but that's it. So UDB 16-bit period 1000, and period is now 1 second. Okay, slowly blinking. There we go. Okay, and now we have an interrupt output here. We now just need the interrupt service routine hook, and that you will get from interrupt component from here. Click, and there we go. So now I have set up the whole system. You can actually also check that this is okay. Derived, yes. Every time you take the signal from a block directly, or this component directly, then derived is the correct mode. All right, so now next thing I will go and click to make the code. So I click the generate application, laboratory design, synthesis, doing stuff. Okay, bitstream, naming, API, cleanup, will succeeded. So basically I can go and start working on my code first the main. The only thing what I need to do on my code here is to start the those devices. Also, basically I have there the timer. I need to start the timer. That also starts the interrupt module, which is inside of it, and also the clock signal starts flowing. Another, I need to also then also start the interrupt service routine. There, good. So those are actually called. So now timer is running, interrupt services is started, and that's all I need to do on the main.c, since I want to do whatever I want to do on the interrupt service routine, just to prove a point. Okay, so I go to the interrupt service routine, and there I actually have the place where I can add. I already actually tried this one, so I have the include project.h here. So I need the prototype for the code to access this blue LED. You can actually either add this one there or add the bled.h. Either or will work. Then I will find the ISR, CY-ISR, which is somewhere here and already filled. This is a shortcut. This is the miracle of videos. So first I read what is the last value I wrote to the output buffer. So data register of output port is actually holding information what was written. So what was the values what we wanted to write to the output. And then actually if that is 1, then I will clear the write bit. Clear this blue LED. Okay, write 0. Otherwise I actually write 1. So in principle this should start blinking, since if it's 1, then the wanted output was 1. When it comes here, then basically it should turn it down to 0. Next time it's not 1 anymore, so it turns it to the 1. Okay, this is a well hidden information. Read these component data sheets carefully. Since on the timer, okay, there is actually these registers, status registers. When you use the timer read status register, it goes and accesses these statuses, and one of those is actually the interrupt. So basically terminal count. So, and this is a so-called sticky register, meaning that it will actually when the terminal count is reached the first time, it goes to 1 and it stays there. And this is also the interrupter source. So practically what you need to do is read the timer status register in order that timer to be able to interrupt again. All right, so that's basically clearing the interrupt. Okay, or actually this is more like a acknowledging the interrupt. There. So in principle now it should be running. So what I do, I'll just build it. Okay. Program it. Then I have my camera ready somewhere in here. And yes, it looks like the blue LED is blinking. Okay, so let's take a quick review. So on the top design, I have the timer set up, very simple way, and interrupting on the terminal count, and actually then I have the interrupt service routine 1 hooked up here, so that component. I have software driven blue LED, and on main I start the timer. I also start the interrupt service routines, and then basically that's all I need to do on this. So we don't do anything on the main loop. And actually I have this interrupt service routine CYISR for ISR1 interrupt and where I checked what was the last value I brought to the output pin register and change the write the opposite value to the output. And to make sure that it actually blinks again, I also need to clear that sticky register bit on timer. So timer status register, you need to actually clear that one. There, but it looks like it's okay, yeah, so those are terminal bits, and the status register are different on fixed and UDP implementation, but it doesn't really make any difference. Anyhow, we have a blinking LED, so yep. The next video would be about PWM and servo motor control and some hints how they actually could be implemented on programmable system on chip creator. Okay,